Found this transmission online. It's pretty bad shape. You can see that it's pretty rotted out. That pulley's obviously frozen on there. I'm going to try to get it off, but I'm probably going to have to cut it off. You can see that the reverse disc is just garbage. That's going to go right in the trash. I have the original spacers from behind it. I think those can be saved. So I'm going to get a puller on here and see if I can pull that pulley off of there. And then if I can, I'm going to try to save that pulley. Also, you can see that the axle shafts are cut off. And that's because it's cheaper to send it in the mail and put a new axle shaft in it than it is to actually ship it with the axle shaft in it. Well over $100, probably $150 to ship one with the axle in it. Probably about $20, 25 to ship it without it. So I just usually have the seller cut them off, send it to me that way, and I'll just put a new shaft in it. So anyway, I'm going to get a puller on it, start oiling it, probably take a week. I'll see if we can get that pulley off of there, and if it doesn't budge, then I'll cut it off, and we'll go from there and see what we got, and hopefully we can save this old girl. All right. New plan. The pulley is not coming off. It's been soaking. I tried pulling it off and I ended up breaking a bolt right in half. Pulled on it so hard. So if you look, here's the keyway right here. So what I'm going to try to do is cut this pulley off. And I'll cut it right across here. So that I cut right next to that keyway. And the idea behind that is to get a split in the pulley without touching the shaft with anything. Above all is to preserve that shaft. So I'm going to try to cut there, and if I miss by a little bit, I'll grind on it and I'll get that pulley to split right at the keyway. And then hopefully I'll be able to get it freed off, give it some taps with a hammer, and we'll see how bad that shaft is, and hopefully won't have to make another one. Now you can see where I've taken my cut. I'm nowhere near that shaft, but I am through the keyway, so I do have a clean cut through there without damaging that shaft. So now what I'm going to try to do is drive that keyway out of there and then try and pry that pulley around, and if not, I'll have to make another cut just to get it from, it's probably seized to that shaft, probably welded right on there with rust. So let's try to get that keyway out and see how that goes, and maybe it'll loosen up. Okay, pulley's off. Didn't go that bad. Worst one I've ever done, actually. So I had to cut it up and pry it off of there, and it was fused right on. So that's gone. Looking at the shaft, the keyway doesn't look too bad here. And the area that actually has a pulley on it is actually pretty good. Now you can see some rust here. And of course the end is really bad. But the area that matters is still pretty good. So I'm going to continue on. We'll tear it apart. See how bad it is inside. And worst come to worst, I'll have to figure out to either replace or make a new shaft. So let's get this thing apart and see what's inside. This input shaft is probably one of the worst parts of the whole thing. So I want to find out if it's any good before I put any effort into making it okay. The races look pretty good where the bushings were, but I want to make sure that when a pulley goes on, it's not going to be flopping around. So I'm going to clean this all up with a little bit of paper and some Scotch-Brite. And we'll get a micrometer on here and we'll find out how bad the shaft is and whether or not it's got to be replaced. Okay, so I mic'd out this shaft, and all the way across it is 0.623, which is only about 2 thousandths smaller than nominal size. 625 would be 5/8. So when I buy my bushings, I buy them small and then I have to hone them to size. And that's what I provide in all these kits to rebuild. So this bushing can be sized to a shaft 2 thousandths smaller. Not a problem. If it were 5 or 10 thousandths too small and just completely worn out here, there would be nothing I can do, because this has to stay 5/8, because if it's too small, your pulley be flopping around. This here on any other shaft could be machined, and then a custom bushing can be made to fit it, which would not be a big deal. So the only option would be to make a custom bushing, turn this whole thing down, and then when your pulley goes on, try to shim the pulley back with some 5,000 shim or whatever half the difference in diameter would be, to try to get it back out to 5/8 so that the pulley properly fits. And if it's only 10 thousandths or something, that's not a big deal, and your keyway will still work out fine. Okay, again, on the other end, we're only 2 thousandths smaller, so this shaft isn't really worn at all, and it's still good. So again, I can just take a bushing, machine it to fit, get a nice solid fit, and this shaft is good. I'm going to try a pulley on it, make sure it's good, but I don't think a pulley's going to wobble at all. I think we're going to be perfectly fine. Okay, jack shaft, we got a problem. This shaft is worn about almost 12 thousandths of an inch. You can see that the bushing is wobbling on it. So I'll polish that up, get a good measurement on it, make sure it's still round. If not, I'll dress it with the lathe and make it round and get it polished up, and then I'll have to make a bushing, brand new bushing. So I'll order up a bar of 841 and make that bushing, press it in the housing, so it'll have the same OD outside diameter, but it'll have a smaller inside diameter and fit that bearing race right there a lot better. So first problem of the day. All right, so I've decided to build this one. Nothing looks horrible, and I'm not going to let that shaft bother me. If nobody wants this one, I'll just use it in one of my own personal cars or keep it as a spare. Not a big deal. So what I'll have to do now is I'll go over to the lathe and I'll start cutting these welds off, and I'll have to harvest this sprocket off the old shaft. So I'll just machine that off and take a couple of pins with a hammer, and this thing will pop right off that shaft. Also too, I got to pop all these freeze plugs out, drive all the seals out. There's 3 of those, and then I'll go through and I'll press all of the bronze bushings out, and then we'll take a look at the case. The only thing I don't see any cracks, but I do see a flat spot across the bottom, and I think that is probably from the previous owner, probably dragging it around, moving it in the garage or around the property without back wheels on it, and it was probably dragging on the ground and they tore it up. So when I go to seal it, I'll put a little extra goop there, but it should seal up no problem. So I'm going to do all that, get the case cleaned up, and get it ready to put back together. Alright, bushings are all out, so time to do some sand blasting, clean up the case. I'm going to blast the outside of the case, of course not the inside. Get it cleaned up so it'll take paint, and then we'll start putting things back together. Alright, out of the blaster, I'm going to put a coat of paint on them, and then we'll clean them up real good on the inside, and we'll be ready to rock and roll. Alright, we're going to let that dry. You don't have to get too carried away here. This isn't really like final paint or anything. You're going to get scratched up and banged up, putting it together and tightening bolts and all that. So we're going to paint it again after it's together. But I just wanted to get one coat on there, get them cleaned up, makes them a little nicer to work with. If you find anything wrong right now, it's a whole lot easier to deal with. And so I always get a coat of paint on them, and then we'll wait until after it's all together to put the final coat on. So I'll give that a chance to dry, and we'll probably start working on this thing tomorrow. Alright, so here's the plan. I'm going to machine this weld off of here. I'll just start cutting it until I get to the depth that the axle is, and I'll probably dig into the axle about 10 thousandths. And then I'll try to undercut it as much as I possibly can. Then I'll flip it around and do the whole thing again. All right, flip it around and do the same. And there we go, saved a sprocket. On these cases, you'll see that there's a small hole here. It's kind of filled up. And again over here. Those are for alignment pins, which are missing on this transmission. Those alignment pins get pressed into one side, and then the two halves come together, and it registers them together. And that's the way they are forever. Now, if you don't have those, then your two halves can move around. And if they move around, you can see how your axle and everything else inside of there could be misaligned. It can cause premature wear on your bearings. So it's kind of important to have those in there. So I'm going to put those back in there. I've made a couple, and I'm just going to drill these holes. I'm going to press them in one side, and then I'll drill a hole just big enough for these to go in easily on the other side, so the two halves can come together, but they won't be able to move around. Alright, you can see them in there. Those are going to get fixed with Loctite. Let them sit for a little bit. And we'll drill the other side and see how that goes. Okay, just to let everybody know, these locating pins were on the McDonough cars and on the crew cut cars. They weren't on Mussolini cars, and the Fry cars didn't have these pins. And I'm not sure about Mini cars. I've never been in one of their transmissions, so I'd be curious to see. But these locating pins are kind of a little bit higher quality. The McDonough transmissions were first class. You could tell. So if you got these pins, you know you got a McDonough. And if they're not there and there's no sign of any holes, you're probably either a Ussolini or a Fry car. And it's not that they're bad. It's just that they don't have them, and you have to be a little more careful when you bolt the halves together to make sure that you're lined up and free, and just to make sure that you don't get all the wear on your bushings, your brand new bushings. So, all right, I'm going to start with the axle bushings, and I'm going to press those in so they're just flush with the inside of the transmission here. All right, next, get my input shaft bushing in. Jack shaft bushing on this side. Now, input shaft backside. All right, now we got to leave this one. I got to make a special bushing for that because that shaft was damaged and repaired. I think that was done by somebody because this is round. And I compared the bushing that I took out of there to it, and it was also smaller. So I think this transmission has been repaired before. So I'll make a bushing for this, and then we'll get started lining everything up. All right, special bushing made. Now I'm going to push this bushing in until it's about maybe an 1/8 inch or a little bit less from going flush. I want it to be sticking out about 1/8 of an inch. All right, let's go line everything up and see where we're at. All right, all the bushings are in now, so I'm going to go true up the axle bushings. I'm going to hone them up for size and alignment. Make sure the axle shaft goes through and spins nice and free. And then after that, we'll work on that jack shaft. Get everything lined up. Nice fit. Let's get the back side of this sized up. Then I'll change over and we'll do all these. All right, change tools, get that input shaft. First thing I want to do is get this in alignment. So I've got these washers. Now these are not available. I don't know where to get them. I've never found a source for them, and I've spent hours looking. So if anybody knows, let me know. But these washers only come in the McDonough Trans, and they come in the crew cut. The others do not have them. They just let the sprocket ride right on the aluminum case. Not a fan, but that's what they do. So I'm gonna put that in there. Put the sprocket on it. Put that in there. And then I just want to tip this up. And I want to eyeball down the edge and see if that chain is running completely straight. And since I left that out about 1/8, because I have done 1 or 2 of these, I would say that is really, really nice. So that bushing is going to stay. Next thing I want to check okay, now you can see, maybe you can't, that the input shaft kind of sticks over the top, sticks about a little bit too far that way. So I'm going to push this bushing in just a little bit more. But I will still leave it out because I want this to ride on the edge of the bushing, not on the aluminum. So I'm going to push it as far as I can that way without it going into the bore. Okay, now also got a situation here where the big gear is rubbing on the top of here. So to avoid that, I'm going to have to push this out a little bit to keep the gear from touching the top of that. So I'm just going to move that just a hair. All right. Now we're not touching there. And our gear is pretty much in the back, even in the back. It sticks out a little bit here, but that's not a huge deal. So now what I want to do is I want to put the gearbox together. I'm going to bolt it together. Then I'm going to push these bushings that way until they tighten up. And that'll keep the shafts from moving side to side. And then when I put my gasket in there, that'll give it room to rotate freely. So without the gasket in there, we're just going to do real quick bolt together. Now if we look here on the McDonough and crew cut, there's a hole you have to drill. And that hole allows oil to get down into the center of this bushing. So once this bushing is all set, it's reamed, it's ready to go, you're ready for assembly, we're going to put a 3/32 drill bit, 3/32 drill bit through there and open up a hole in there so it can oil. So let me get that done right now. Well, we have our axle welded, sprockets on, so now we're going to put some seals in. Get our seals in, and then we also need to put in these little freeze plugs. And you can see they're concave, I guess you would call it. When you put them in, you put the bow up. You put them in, there's a little ridge they sit on, and then when you push on them, it'll flatten it out and spread it out so it'll be trapped in there. So what I like to do is put just right on the edge, put a thin coat of gasket sealer on there. And no sense doing all this and have one of these leak. So just right on the very outside edge, just put a little line. Then when you put them in there and smush them out, they should be leak proof. So let's get that done. Seals in, freeze plugs are in, and you can see, I don't know if you can tell on there, but there's a flat spot on the top. You can see where I pushed on them. Just took a little metal piece and pushed on it and flattened it out, and it's all sealed up in there. So now I'm just going to put the axle in. I'm going to get it clamped in the vise and get it ready. So what I have to do is put that in there. I'll slide the axle shaft in, and then I'll put it in the vise and get ready to build it. All right, we got to get our chain on. And that's going to be a combination of both of these. So I've greased the axle. Now I want to get some grease on everything. If metal touches metal, put just a real thin smear of axle grease, just for assembly. The 90 weight will take over eventually. And I'll open the vise and let it drop in. So now I want to get this all cleaned up, get some gasket maker on it. I'll put my gasket on, and then we'll bring the two halves together. All right, now I'm going to put my gasket on, get that semi lined up and kind of glued on. Now that sealer I put on is a very, very thin coat. Very thin. Get our input shaft in. And we'll get the other half going. Alright, gasket on. We got to get this cleaned up, get some gasket sealer on there. And together we go. Back together. Now I've just got everything snugged up a little bit. What I like to do is snug it up, let it sit for a couple of hours, turn into some gel, or maybe get a little set up a little bit. Then I'll go back and final torque it. I don't torque it right away because I don't want to squeeze all the gasket sealer out of the crack. So we're going to let this sit. And I can tell right now that we're probably pretty good because I can rotate the transmission. Watch the input shaft turn. It's a little bit stiff. I kind of expected it to be because the fiber washers in there are a little bit deformed. So, all right, so here's the break-in. I'm just going to run it in for probably a couple of minutes just to see how it does. Then I'll turn the RPMs up and keep bumping it up. But I'll run it in for probably about a half hour and just let it go. And everything will loosen up and get well oiled, wash all that grease out of there, and all the 90 weight oil will take over, and she'll be ready to go in a car soon. So this is what I do. Now again, you can do this with a drill motor, or you could do it right in the car. Just put it in the car and let it go, and it should break in. If it's still tough, if you can't grab the axle, turn the axle and have the input shaft turn, then it's probably a little too tight, and you might want to try to figure out why. But it's a good test, because when it's in the car, you're going to want to push the car around, and you're going to need that axle to be able to turn the input shaft, or you won't be able to push the car. So make sure you're loose enough so that you can just grab the axle and give it a twist and the input shaft spin, and then you'll know you're real close. And if it's just a hair tight, and it's then try running it in. But if it just won't move at all, you're going to have to take it back apart, try to figure out where the tight spots are, and get it to spin so that you're able to move the car around without having to pick the back wheels up off the ground. So anyway, that's what I do, and we'll give it, when this is over with, we'll give it the final test. And if it passes, I'll go on the shelf and be ready to go in a car. Alright, that other transmission is breaking in, but I wanted to just show you this. I can take this axle and actually spin the input shaft when I grab the axle and turn it. And that's what you want. You want to be able to back drive the transmission, turn the axle, and move this pulley. And if you can do that, you'll know that you'll be able to push your car around comfortably. So when you can do that on your transmission, then you're good. So if it seems a little tight, like I said, just keep running the car. And if it's real tight, then you may have to go back in there and find out why. But anyway, that's what I do, and happy motoring.